Welcome to this video segment from Watertown STEM. We will be identifying the 3D printers we are currently using within the Watertown Unified School District, doing a little research on our plastic filaments, and showing where to find our slicing software, CURA. Let's get started. As of winter 2018, WUSD has over a dozen 3D printers around the school district. Currently, they are Maker Select printers from Monoprice. Monoprice has a few 3D printers available, all open bed style with single extruder heads. We currently have both the V2 and the Plus printers. They are relatively cheap in cost printers for the market, though have been doing okay for us the past 12 months with a few fixes along the way. With a quick internet search, you can see many 3D printers available on the market, including some more common names like MakerBot, Dremel, and Ophinia. The Monoprice printers are shown here. The V2 uses a micro SD card to run your files from. We have other videos available on loading your files, adjusting the bed height, and doing some routine tasks with this printer. The plastic filament we are using is PLA, or polylactic acid plastic. A quick internet search shows some basic properties of the two main plastics available for 3D printer, though there are many materials available nowadays to print with. PLA and ABS are the two most common plastics used for printing, and PLA is what we are using on the Maker Select printers, as we do not have an enclosed area for printing. PLA is more forgiving and can be printed at room temperature without many issues. ABS is more common in useful parts to be fabricated beyond just fun, though requires more care in printing. As shown on Monoprice, these are the spools we order for our printers. If you are ordering your own, be sure they are PLA, not ABS. There are various colors available within all print filaments for the most part, especially with the PLA. Most of these colors come in full 1 kilogram spools, although some only come in half spools, which still work the same. In looking at these print spools, conveniently on their website, if you scroll down, you'll see some properties, including the printing temperatures recommended for the plastic. This particular one says 210 degrees. However, a pretty common range is anywhere from 190 to 220. We'll get more in depth in that in a future video when we are actually using the slicing software. Now that we have our printer and filament chosen, it is time to find our slicing software. Monoprice and Maker Select suggest the use of CURA. Though there are other softwares out there if desired, CURA is a free software for download and is pretty common in finding tutorials online. To find CURA, just do a Google search for it. And you should see the Ultimaker website who provides the software. Go ahead and download the latest version and put it on your computer. This software talks between your 3D CAD model and the 3D printer through slicing your file and creating the print file. Some may use the term Gcode in the CNC world, where mathematically it is providing the X, Y, and Z coordinates for the printer to do its work. As you can see from CURA's website, we have the 3D model, we have it creating slices, and we have the printing. If we were to look at a quick printed part in CURA, this is the slicing software known as CURA. We can load a simple file, which we have a future video on this with all of our settings and why they work. But if we go into layer view, you can see how it's going to print each layer, one layer at a time, building up to the final product. Another piece that many people tend to ask is, how much does it cost to 3D print? Well, doing a quick little search or research on that 1-inch part I just had in CURA, we could do some very quick estimating or breakdown of the cost. That 1 cubic inch of part is about 10 grams of plastic. A full spool of plastic is a kilogram or 1,000 grams. So that 1 cubic inch part is 1/100th of a spool. If a spool is around $20, that means that 1-inch cube is around 20 cents. That part takes approximately 40 minutes to print, though that can vary greatly on what settings you choose, the speed, the quality, all that can adjust as well. So estimating out a cost could be around 1/2 penny for every minute. Though there are many mistakes and changes in the parts, an estimate for cost, if you were charging out a part for some reason, would be 1 penny per minute of print time. Well, that is it for this video segment from Watertown STEM. Check out our other videos to gain more experience around these 3D printers at Watertown Unified School District.